Hey ladies, so today we're starting chapter 8 and we are doing logarithmic functions in this unit. So just be aware there, this unit is 8 hours long, so we're going to have 2 lessons, we'll have a quiz, then we'll learn 2 more sections, then we'll have an assignment, a review, and then a test. So it's pretty short, just like the other, like the last unit. So just be aware of those dates there, okay? And the outcomes that we'll be learning this unit, the biggest one here is our PC 30.9, and basically we're going to be studying understanding logarithms. That's by evaluating logarithms. We're going to be deriving laws of logarithms, solving them, graphing them. We're doing all of that wonderful stuff, and some key terms that we'll be looking throughout this unit will be a logarithmic function, a logarithm, common logarithms, and logarithmic equations. All right. So moving on to section 8.1, here we're basically just going to be, this section here is just, we're looking at just the basics. So what is a logarithm, and we're going to work on understanding what a logarithm is. So to start, last unit we looked at exponential functions, and the inverse of an exponential function, say we have y is equal to c of x, and the inverse is x is equal to c to the power of y. And this is actually what a logarithm is. So the logarithm is the inverse of your exponential function. So we can say that this expression can also be in the form y is equal to log to the base c x, where c is greater than 0 and c can also not be 1. So with those c values, that's basically just what we looked at last unit when we had exponential growth and exponential decay. So that's when c was a fraction or it was greater than 1. And so what we can call these forms when we write it as y is equal to log cx. So those ones we actually have names. So those are called logarithmic functions. Okay, so those are called logarithmic functions. And in this form we call y the logarithm to the base c of x. So that's essentially when we're just talking about it, we would just say that y is the logarithm to the base c of x. So just when we're talking about it, but this is essentially how we're going to be looking at it mathematically, right over here. Okay, so looking at this, I gave a nice little graph, or not a graph, a little picture about how this would look. So say we have the function y is equal to c to the power of x. So this is our original function. If we were to take the inverse of that function, it would be c to the power of y is equal to x. So if you notice there, you switched the x and the y values. Okay, so that's when you take that inverse. And then if we were to write our inverse function, if we were to write that as a logarithmic function, we'd have log to the c, so I guess the base of c, x is equal to y. So this is kind of how we would write it. And sometimes it's a little bit harder to know when, or to remember how we're supposed to write this as a logarithmic form. So there's actually a nice little saying here. So we have, say, Ben the log bunny. Might sound a little bit crazy, but this in itself will help you to remember to switch from exponential form to logarithmic form. Sorry. So first we'll start off, say we just had some exponential function, b to the power of e is equal to n. So actually right here is ben. So your base, your exponent, and the number that it's equal to. Okay, so we have ben. And we could rewrite that using the log bunny. So we would write that as log to the base b number is equal to n. So we have log b n e. So if you kind of say that's bunny, it's a bit of a stretch, but hey, you know what? If it helps you, it helps you. That's great. So what you do is, so b is that base number, so that becomes a little subscript here. Then your number, or what I guess that'd be your x value there, would become that number just on the outside of that, your subscript, and then that is all equal to your exponent, or e. So if you guys need to, that's actually, I find that super helpful for when writing this, so repeat it. So Ben the log bunny. So you have Ben, that's going to be your exponential function. Then to write into logarithmic function, it's log bunny, so base, number, exponent. So you can remember that order. All right? So moving on, one thing that we hopefully should remember from elementary school is that our number system is based on powers of 10. And so logarithms with base 10 are widely used, and we call these common logarithms. Alright, so when we're writing these types of logarithms, we don't actually need to write that base. So here's an example. So here we have the log of 3, and what that really means is that we have the log with that base 10, 3. Okay, so it's kind of like when we're writing, say, 1x, we don't need to write that 1 value there, we just write that as 1, or say x plus 0, we just write that as x. It's kind of one of those things where, you know, we don't, it's just there, and we don't need to write it again. So that's kind of what, I guess that's essentially what that's saying. So if you ever see something without that base, you're just going to assume that that base or that c value is equal to 10. Okay. All right, and one last thing here is that I just want to point out, when we're reading 10 base or log base 10 3, essentially what that right there is saying, it looks crazy, and you know, you're just like, where is this going to come from? But essentially what that right there is saying is, what power must we raise 10 by to get 3? So that is essentially all that a logarithmic function is saying. What value or what power must we raise 10 by to get 3? Alright, so let's look at some examples here. We're going to, in the first example here, we're going to be switching to different forms. So whenever we're given an exponential function, we're going to rewrite it as a logarithmic function. And whenever we're given the log form, we're going to switch it back to that exponential form, okay? So that first one here, we have 3 to the power 4 is equal to 81. So this right here is our exponential form. We could say that that is b to the e is equal to n. We need to change that into a logarithmic form. So that is log b n e is equal to e. So remember, Ben the log bunny. Alright. So here in this example, our base is 3. The exponent is 4. And that number there is 81. So we're going to rewrite this as log base 3, n is 81, is equal to 4. Alright? That's all you have to do. So remember, Ben the log bunny, then you guys can label, I guess if you want to, what each of those numbers mean, and then from there just put it into that log form. So log to the base b, n, is equal to e. Alright? So let's look at the next one here. We have 36 to the power of 1/2 is equal to 6. So there we're given, once again, an exponential form. So we need to change this back into logarithmic form. So here, 36 here is b, our base. 1/2 here is our exponent. And 6 here is that number that 36 to the power of 1/2 is equal to. Okay? So here we have log to the base 36, where the number is 6, and that is equal to the exponent of 1/2. Okay? So maybe it's not so bad with Ben the log bunny. Just remember that, keep that in mind, and hopefully being able to convert it from different forms should hopefully not be so bad. Okay? So now in these next two examples, here we have logarithmic form, and we need to change that back into an exponential form. So that's where we want this Ben here. We don't want bunny, we want Ben. Okay? So here we have a base of 5. The exponent is 3. And our number here is 125. Alright, so base of 5, exponent is 3, is equal to 125. Okay, you guys can even check that into your calculators. 5 cubed is, in fact, 125. That's also, I guess, a kind of a cheat sort of way that you can check to make sure that you did it right. But hopefully you guys can remember you have your Ben the log bunny. So your BNE is 5 to the power of 3 is equal to 125. Here for our fourth example, we have log of 10,000 is equal to 4. So remember, this one here doesn't have a base, so what does that mean? That means that that base is equal to 10. Okay? So then our number there is 10,000 and our exponent is 4. So rewriting that, we have our base of 10. The exponent is 4. That is equal to the number, which is 10,000. Okay? So moving on to question number 2. Here we need to evaluate each expression. So here we have log of base 2, 32. And how we're going to evaluate is we're going to rewrite this back into exponential form. So remember, we have our base is 2. Our number there is n. And when we're not given, say if it's equal to anything, let's just let our exponent be some sort of variable, and let's just label that y. How does that sound? All right. So using that bend the log bunny, we have our base is 2, our exponent is y, and that is equal to 32. From there, what we'll do is we're going to rewrite this 32 here. We're going to rewrite that as a base of 2 to some sort of exponent. And if you guys remember what 32 is, that is, so we have 2 to the power y. 32 can be written as 2 to the power 5. And then using our exponent rules, you guys should remember that from last unit, as long as the bases are the same, all we have to do is look at just the exponents. So we'll say that y is equal to 5. And a good way to check this is, say, plug in your exponent there of y is equal to 5. 2 to the power 5 should equal 32, so that should make sense, all right? So for b here, we have log of base 100, 10, and let's say that, well, let's let that equal to y again. So here we, to solve this or to evaluate, we're going to rewrite this in exponential form. So our base here is 100, our exponent is y, and that is equal to 10. So to start off, normally, well, what we did like last time here, we changed this to an exponent to match this base, to match that left-hand side, that base. But in this case, that can't happen. What we're going to do is we're going to rewrite this base, the left-hand side base, to look similar to our right-hand side. So 100, if you think about what that is as a base 10, that is 10 squared. We still have that y out there, is equal to 10. Then we can apply our exponent rules and rewrite that as 10 to the 2y is equal to 10. If you guys want to, that is, remember that's the exponent of 1. So now that we have common bases, now let's just look at those exponents. So we have 2y is equal to 1. I'm just going to keep writing over this way. So to solve for y, you're going to divide each side by 2. And what you find that y is equal to 1/2. So what it's saying there is that we're going to square root, or that's what the 1/2 fraction means. So if we square root 100, we should get 10, which, if you guys remember, that's exactly what the square root of 100 is, with the exception of the plus or minus, but we'll just look at it just this way. So 10 is our number. So what do we have to do to 100? What kind of exponent do we have to raise it to make it equal 100s, or sorry, 10 there? All right. And there we found y is equal to 1/2. All right, so for c here we have log to our base 4 of x is equal to 3. And just to note there, this x here is your n, and 4 is your base there. So I just want to make that a little bit clear. It looks kind of a little bit awkward there, but just to make that distinction, this x here is our n, and 4 here is our base, okay? So here we need to evaluate. So let's write this into exponential form. So there we have bn, and here's our e. So here we have our base of 4 to the exponent of 3 is equal to x. Alright, and from there you guys can just put that into your calculators if you guys know what 4 cubed is, and you guys would find that 4 cubed is equal to x. So this one's really nice because our exponent here is just by itself, and then we just solve our left-hand side here. So that one actually turned out to be super nice. So hopefully, you know, it's always nice to get some easier ones like that versus the ones that we looked at above. So we're getting close to that 15-minute mark there, ladies. So we're going to switch over to video number 2.